Good morning, children. We are proceeding to one of the most interesting concepts, counting. What are the variety of counting techniques we are going to learn in this section? Under counting, we have two important principles called multiplication principle and addition principle. Multiplication, the word and will come to highlight multiplication, and R will come for addition principle. How do I understand it? There are two jobs, let me say A and B. How many jobs? Two jobs. This A job can be done in M ways. This B job can be done in N ways. My question is, go do both the jobs. If I tell you A and B, that is multiplication principle, how many ways can you perform A and B? Tells me M into N. How many ways can you perform A or B? Here I say M plus N. So notice in all the word problems in this chapter as well as in probability, we come across these words and are. So and tells me multiply the two ways. R tells me add the two ways. Either A or B tells me M plus N. Whereas A and B tells me M into N. The next idea, you are given factorial symbol. What do you mean by this word factorial? When I say 0 factorial, you treat it as 1. 1 factorial is also 1. This is by convention. What is 2 factorial? 1 into 2. What is 3 factorial? 1 into 2 into 3. And what is 4 factorial? 1 into 2 into 3 into 4. That is 24. So like this, I can keep on writing factorial. This symbol we call as factorial. 2 factorial, 3 factorial, 4, all these tell me start from 1. Keep on multiplying next numbers till I get that number. If it is 3 factorial, stop with 3. If it is 4 factorial, stop with 4. Now tell me what would be n factorial. N factorial can be written as 1, 2, 3 and so on up to n. Can I rewrite this in any other model? Look at this. 1, 2, 3 can be written as 3 factorial into 4. The same idea for n. The previous number is n minus 1. So I can write it as n minus 1 factorial into n. So most of the problems we use these ideas. N is a general number. The next number means add 1. The previous number, how do you get 3 from 4? 4 minus 1 is 3. So for n, previous number is n minus 1. For n, the next number is n plus 1. Tell me one more. What is the next number for n plus 1? It is n plus 2. What is the previous number for n minus 1? N minus 1 minus 1. That is n minus 2. So we must be able to write with n also. Whenever I need to write the previous number, subtract 1. Whenever I want to write next numbers, add 1. So these are the techniques that we use in this exercise. Exercise 4.1, question number 1. In a restaurant, 10 Indian and 7 Chinese food items are available. How many ways can a man select Indian or Chinese food? When we read the question, underline the word R. R tells me add it. How many ways to select Indian food? There are 10. How many ways to select Chinese food? There are 7. Number of ways to select Indian or Chinese tells me the word R tells us to add. So 10 plus 7. So the answer is 17. Second subdivision, there are 3 types of toy car and 2 types of toy train are available in a shop. Number of ways to select a toy car and a toy train. So we will write as before, number of ways to select a toy car. How many cars are available? 3. Number of ways to select a toy train. How many train types are available? 2. The question is and now. So number of ways to select a toy car and a toy train tells me multiplying. The word are tells me to add and the word and tells me multiply. 3 into 2, 6 ways is my answer. Third subdivision, how many 2-digit numbers can be performed using 1, 2, 3, 4, 5 without repetition of digits? 2-digit numbers. So draw boxes. I have to fill here and here. 1's digit, 10's digit. What are all given to us? 1, 2, 3, 4, 5. Can I use 6? No. I should use only these numbers. How many given in hand? 5. Out of the 5, any one I can choose. This or this or this or this or this. How many ways? 5 ways. So this place is done by 5 ways. Out of the 5 numbers, 1 number is gone. Any one number. How many remaining? 4. So the second place I can do only by 4 ways because repetition is not allowed. Repetition means here 1 comes, 1 should not come here. So there are 5. 10's place 5 ways. 1 is gone. 4 are there. The remaining any 1 will come means 4 times. So 1's place is done by 4 ways. 10's place by 5 ways. Number of 2 digit I have to fill both. 10's place and 1's place I have to fill and tells me multiply. So 5 into 4, 20 such numbers we can form. Fourth subdivision, 3 persons enter into a conference hall. There are 10 seats. How many ways can they be seated? Number of seats available for first person. How many seats are there? 10. Out of the 10, any one place he can go and sit in 10 ways. Now out of the 10, the first person is occupied one place. How many places remaining? In 10 places, any one is sitting, there are remaining 9. So second person can sit in any of the 9 places. And the third will sit in any of the 8 places. Now we want all the 3 to be seated. So all the 3 tells us first and second and third and tells multiply. 10 into 9 into 8. So 720 ways they can be seated in the 10 chairs. Fifth subdivision. In how many ways 5 persons can be seated in a row? There are 5 seats. We need to arrange 5 persons. So 5 in hand. First person can occupy any of these places or first seat can be occupied by any of these 5 ways. Second seat by the remaining 4. Third by the remaining 3 and then 1. So multiply. So if you want to avoid writing, you can simply put seats like this, multiply and write the answer. So how many ways? 120 ways we can arrange 5 persons in a row with 5 seats. Take and write the answer. Number of ways for 5 persons to sit in 5 places equals 120 ways. Question number 2, subsection 1. A mobile phone has a passcode of 6 digits. 6 distinct digits. Find the maximum number of attempts to retrieve the code. How many digits do we have? 0, 1, 2, 3 up to 9. There are 10 digits. How many digits we need to form? Only 6. The word distinct tells me One number should come only one. Maximum number of ways to retrieve it. From 10, we are going to frame 6. So first place by 10, second by 9, then 8, 7, 6, 5. Multiply it all and write the answer. 151200. So this many ways we have to attempt to retrieve the passcode. Second subdivision, given 4 flags of different colors. How many different signals can be generated if each signal requires the use of 3 flags, one below the other? So we are going to form a signal with 3 flags only, but there are 4 flags. So first place, out of the 4, 1 will come 4 ways. There are remaining 3. Anyone can come here, that is 3 ways. Remaining 2, anyone can come here, 2 ways. Multiply, so there are 24 ways to generate the signal. Question number 3. There are 4 children running in a race. In how many ways can the first 2 places be filled? Second, in how many different ways could they finish the race? The first section asks 2 places alone. How many children are running? 4. How many ways can you fill the first place? Out of the 4, 1 child will come as the first person. The remaining 3, any one will occupy the second place. So what is the answer? 4 into 3, that is 12. So we will take and write first 2 places be filled in 12 ways. Second subdivision, in how many different ways could they finish the race? How many are running? 4. Out of the 4, number of ways to fill the first place. Out of the 4, any one will come. So 4. Then remaining only 3. Second place by 3. Third place by 2. Fourth place by 1. So the total number of ways will be multiply all and write it. Number of ways to finish the race, 4 into 3 into 2 into 1, that is 24 ways. Question number 4. Count the number of 3-digit numbers with 2, 4, 6, 8. Under 2 heads, repetition is allowed, repetition is not allowed. How many digits are given? 1, 2, 3, 4 digits. What are the 4 digits? 2, 4, 6, 8. We want to form a 3-digit number. Ones place, tens place, hundreds place. Repetition allowed. How many given in hand? 4 digits. Here 4 can come. 2, 4, 6, 8, anything can come. Repetition allowed tells me again 4 in my hand. So again 4 can come. Again 4 can come. So when there are 4, every time the 4 are available because I can repeat the digits. So what is my answer? 4 into 4 into 4, 64 ways we can finish it. Repetition is not allowed tells me hundreds, tens, ones place to be filled. Hundreds place. There are 4. Any of the 4 will come. So 4 ways. Repetition not allowed. So the number here should not come again. How many in my hand? 3. So only 3 can come. Again repetition not allowed. Only 2 remaining. Understand the idea? Repetition allowed. It is 4 into 4 into 4. Repetition is not allowed. It is 4 into 3 into 2. To present it in statements, number of ways to fill hundreds place 4, tens place 3 and ones place 2. Total number of ways will be to multiply 4 into 3 into 2, we get 24 ways. Question number 5. How many 3-digit numbers are there with 3 in the unit place? 3-digit numbers. So ones, tens, hundreds. Repetition allowed. Condition is 3 is in the units place or ones place, I can say. I need to fill only these two places. How many digits we know? 0 to 9, 10 digits are there. Hundreds place, can 0 come? If 0 is in hundreds place, it will become a 2-digit number. 0 should not come here because the question is a 3-digit number. So, even though 0 to 9, 10 digits are given, do not put 0 in hundreds place. You can put any number from 1 to 9. How many ways? 9 ways. 3 is filled already in one way. There is no other change. 3 is fixed. This place 9 ways. Tens place no condition. Repetition allowed. Any number can come any number of times. So all the 10 digits can have a chance to come here. 10 ways. So what is the total? 9 into 10 into 1, that is 1 way. 9 into 10 into 1, which is 90 ways. When repetition is not allowed, already 3 is fixed in ones place. 0 should not come in hundreds place. 3 should not come because repetition is not allowed. One number can come only one time. So 0 should not come, 3 should not come. There are 10 digits in my hand, out of which 2 digits cannot come. So hundreds place, 1 to 9 only can come, 0 mustn't come. And also remove 3 which is already in ones place. If I remove 3, 9 digits, I am removing this 3, 1 digit. Totally there are only 8 ways. In tens place, this ones place and hundreds place, whatever is coming should not come. 0 to 9 can come here, but repetition is not allowed. So ones place and hundreds place number should not come here. So 2 numbers you subtract. So out of the 10, remove the 2 numbers. So 8 ways. So what is the total? 8 into 8, that is 64 ways, and that is the answer. Question number 6. How many numbers are there between 100 and 500 with the digits 0, 1, 2, 3, 4, 5? Repetition is allowed and repetition is not allowed. 3-digit numbers will be between 100 and 500. 100 tells me 1, 2, 3-digit number. 500 also tells me 1, 2, 3, 3-digit number. Starting from 100, ending with 500. So, first place, 0 should not come obviously. 1, 2, 3, 4 can come. I cannot start with 5 because my question is up to 500 only. So this place 1 to 4 only can come. How many ways? 4 ways. Tens place no restriction. Repetition is allowed. 0 to 5 any number can come. So 0 to 5 my answer will be 6 ways. 0 to 5 if you count there are 6 ways. Ones place. My question should end with 500. I cannot have 501, 502, all that. But in hundreds place, I have taken only 1 to 4. We didn't take 5. So, any number can come here from 0 to 5. So, 0 to 5 tells me 6 ways. So, total, my answer is 4 into 6 into 6, that is 144 ways. Second subdivision, repetition is not allowed. When repetition is not allowed, as before the same discussion, hundreds place 1 to 4 only can come. 5 cannot start because I want up to 500. So 1 to 4, 4 ways only. Tens place, any of the 0 to 5 can come, but hundreds place must not repeat because repetition is not allowed. So hundreds place whatever comes I should avoid. So 0 to 5 there are 6 digits, but this digit must not repeat. So totally 5 digits are available. In ones place also no restriction, 0 to 5 can come, but subtract tens and hundreds place number. Again repetition not allowed. So tens, hundreds place I must subtract. So if 1 comes here, 2 comes here, that must not repeat here. So subtract whatever is coming in tens and hundreds. So totally there are 6, but I am subtracting these 2 places. So only 4 can come. So what is the total that I get? 4 into 5 into 4, that is 80 ways. So total number of ways when repetition is not allowed is 18.